Hello. Today we're going to talk about 11.1 permutations and combinations. So let's start off with some basic probability questions. So number one, how many different outfits can you make if you have 3 pairs of pants and 2 shirts? All right, so if I list out my 3 pairs of pants and then my 2 shirts, now find all the different combinations. 1, 2, 3, 4, 5, 6. All right, so there are 6 lines combining all the different pants and shirts. Okay? Now for question 2, you have 4 sandwich choices, 3 sides, and 4 desserts. So you have sandwiches. Right, you can label them like this too. 1, 2, 3, 4. Then you have your sides. Ooh, I should have labeled those different. Let's just call them X, I guess. X1, X2, X3. And then you have 4 desserts. All right. Now, you can sit there and just find all the different combinations. So with one side, and I'm sorry, first sandwich, first side, then you can have 4 different desserts. So with each one, got me 4 desserts. Then I do the first sandwich with the second side, and then I get 4 different desserts I could pick. So that's 4 different ways. All right, and then I can continue. And then the first sandwich, third side, gets me 4 different desserts. So with just one side, I can get, with one sandwich, I can get 12 combos. So if I just replace that sandwich with each one of these, well, that just gets me 4 different sandwiches gets me 48 combos. So how many different meals can you make? 48. So now we can use, that's just using the fundamental counting principle, literally listing everything out, okay, finding all the different combinations. There's a much easier way to do this, okay? Maybe you've noticed. All right, it's literally just multiplying. There are 3 pairs of pants times 2 shirts gets us 6 outfits. 4 sandwiches, 3 sides, 4 desserts gets us 48 combos. All right, for number 3, we have a license plate. We have 3 letters and 3 digits. So, letter, 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 digit, digit, digit. Okay, well, how many letters can I choose from? Well, there are 26 letters in the alphabet. That's the first choice, the second choice, the third choice. Then digits. Well, there are 10 digits. Don't forget to count 0, right? 0 to 9. So there are 10 digits. And then you just multiply. All right, where's my calculator? All right, I get 1, 7, 5, 7, 6, 3 10s. Okay, so 17,576,000. All right, that's just 3 letters and 3 digits. And that's doing it in that order. Letter, 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 digit, digit, digit. Okay, imagine if I changed up the order, okay, things would change. But we'll get to that. When we want to discuss order, that's a permutation. Okay, you have to remember that. Permutation is order. So, suppose you wanted to find the number of ways to order the letters A, B, and C. Well, I can have A, B, C, or A, C, B. BAC, BCA, CAB, CBA. All right, so there are 6 different ways to order the letters A, B, and C. Now, that's of course the long way to do it. There's of course a shortcut. When you're doing permutations, you can also use factorials. We're now using exclamation points in algebra, right? Isn't that great? Math is so exciting. We're finally using exclamation points. It's great. All right, so a factorial is just multiplying that number times all the numbers below it. Okay, so don't let the formula confuse you. You just plug in a number. So we plug in 4. Well, 4 minus 1 is 3. 4 minus 2 is 2. And we keep going until we get the number 1. So 4 factorial is 4 times 3 times 2 times 1. 10 factorial is 10 times 9 times 8, 7, 6, 5, 4, 3, 2, 1. Why do we stop at 1? Well, because the next number would be 0. If we multiply by 0, well then it's every factorial is 0, and that's kind of useless. So we stop at 1. So if we want to file 12 folders, one after another, well, okay, let's see how this works. Go back to the last problem. All right, if we're doing permutations, okay, there are 3 choices. So the first choice, you have either A, B, or C. So I have 3 choices there. For my second choice, I only have 2 options. A is either B or C. Once you choose B, it has to either be A or C. Once you choose C, it has to either be A or B. You have 2 choices. And then once you've already picked the first and the second letter, the third option is set. So 3 times 2 times 1 is 6. So if we want to file 12 folders, one after another, right, they're all different folders, how do we do that? You do 12 times 11 times 10, and we keep going. All right, we do that, all right, because the first folder we pick we have 12 options. Once we've picked it, we've only got 11 options to choose from, right? Because we don't put the folder back, right? We're putting them in the cabinet. All right, so then we would actually work this out. So we would get out our calculator. All right, and on our calculator, we can hit 12. If we go to math, then go over to probability, and then scroll down to number 4, we see the factorial. So 12 factorial is this. All right, now for the next problem, number 5, arrange 8 shirts on hangers. Well, you pick the first shirt, you have 8 options. The next shirt, you have 7 options. Then 6, 5, 4, 3, 2, 1. All right, you multiply that, you get 40,320. Okay, so that's a permutation. All right, this is also great if we're using all the hangers, but what if I only have 4 shirts to hang? Well, how many different hangers can I pick, right? That gets a little trickier, right? Then we're going to use a formula, okay? So this is a selection where order matters, and we pick n items out of r items. So out of n items, we pick r items. Sorry, I said that backwards. All right, so number 6. So we have 10 students that are in a race. How many different ways can we take those 10 runners? Can we have them finish first, second, and third? So if I have 10 people, right, how many different ways can I make the top 3? So that would be 10 picking 3. So we do 10 factorial over 10 minus 3 factorial. Well, that's just 10 factorial over 7 factorial. So 10. All right, let me write this all out. And then we have the bottom. All right, now we could work this out and use our calculator, but we should also see something, right? We can cancel a lot of these, right? Any of those pairs, it's all multiplying and dividing, so we can do shortcuts, right? It's when we see addition and subtraction, we can't do shortcuts. So now we just have 10 times 9 times 8, so our answer is just 720. So there are 720 different ways we can make first, second, and third place. How many ways can 15 runners finish first, second, or third? So do the same thing. All right, we can do 15. We're picking 3 of them. Order matters, first, second, third. So we do 15 factorial over 15 minus 3. So that's 15 over 12. That simplifies to 15, 14, 13. And let me get out my calculator. Oop. Gotta hit the right buttons there. All right. We get 2,730, which would make sense because if it took 700 ways to get 10 people, 15 people should have more options. Okay? Notice how much more. That's quite a bit of difference, right? All right, so that's a permutation. So now we got to talk about combinations. Okay, what about when order doesn't matter? Okay, so if I'm just taking 13 items and I'm just going to take 4 of them. So I'm like picking groups. Okay, so I've got a class of 30. How many groups of 4 can I make? Right? It doesn't matter who's in my group of 4. I didn't say, you know, if I say Allie, then John, I didn't say Allie was first and then John was second. I could have said John, then Allie. It doesn't matter the order of me calling them. They're still in the group. Okay? So combination, it doesn't matter the order. I picked a group. Okay? They're all equally important. Okay? So here we have 13 choosing 4. Right? Just choosing a random amount of 4. So that's now 13 factorial over 4 factorial, 13 minus 4. So we get 13 over 4 times 9. The 13 and the 9, that cancels. A lot of good stuff. Then we're left with just 4, 3, and 2. So let's see. I'm going to go ahead and cancel out the 12s and make that a 5. So 13 times 11 times 5, we get 715. Okay, so now that you know the formula, all right, this is how I expect you to show your work, all right? I want you to make sure that you are putting at least this down on your paper. I want you to see the formula in action, okay? You could also use your calculator, right? Especially if you're going to A&I, Applications and Interpretations, IB, you're allowed to use your calculator. If you don't plan on doing that, don't look at this. So if I want to do 8, choose 3, I hit the math button. I go to probability, and that's what NPR and NCR are. So NCR is our combinations. Notice it took my answer. That means that's my N value. I don't want that answer to be my N value, so let's replace it with 8. Then the button after it would be your R. Oops. Okay. So then you hit 3, and it does the work for you. All right, so here, to show your work, I'd want to make sure you put 8 factorial. Oh, let me do a different color. Let's go to green. So we'd have 8 factorial over 3 factorial, 8 minus 5. Know that formula. And then the answer was, what, 56. Part 10, or number 10, you have 9 factorial over 2 factorial, 7 factorial. All right, actually, I could just do that one in my head, right? That's 9 times 8 over 2. 4 times 9, right? Don't overthink it, okay? All right. Now, how do we know which is which? Permutations or combinations? So try to determine if it's a permutation or combination. Don't solve it yet. Just see if you can get that right. Okay. So number 11. A chemistry teacher divides her class into 8 groups. Each group submits one drawing of the molecular structure of water. He will select 4 of the drawings to display. How many different ways can he select the drawings? Well, he's displaying them. Did he say how he's displaying them? Just up on the board. So does it matter where he puts your drawing? No. Okay, so order doesn't matter. It's a combination. So this one is 8 choose 4. 8 factorial over 4 factorial, 4 factorial. I'm going to use my calculator. Hold on, sorry. 8 choose 4, and we get 70. All right, the next one is you draw winners from a total of 25 tickets in a raffle. First ticket, second ticket, third. How many different ways can you draw the winning tickets? Well, does it matter if you get called first or third? Yeah, look at that difference. I'd rather be called first, wouldn't you? So this is a permutation, right? I know it was 50-50 chance here, okay? But yeah, you want to know the difference. So here, order matters. So this is, let's see, 25, and we're picking 3 of them. So 25 over 25 minus 3, so 22 factorial. So that's just 25, 24, 23. So this would be 13,800. All right, don't be afraid to ask me questions. I know this stuff is weird. Statistics and probability is one of those things you can feel really confident, and I make it sound super easy. And people overthink this every single day, and they get it wrong. I can't tell you how many times I've seen in the news they've messed up statistics and probability. Okay, the wording is all wrong. So please, please understand this. Please, please ask me. Okay, don't be afraid to ask. Okay, it's very confusing for most of the people out there. Okay, so the best way to combat that, ask me questions. All right, I'm done ranting. Come to class.